Assalamu alaikum viewers. This is Engineer Sadakat Ali and you are watching my YouTube channel Real Time Simulation World. So today in this video we are going to learn about different data types in LabVIEW and how you can troubleshoot and debug your LabVIEW VI. So let's get started. Uh, so there are different types of data available in LabVIEW. You have double, you have integer, you have boolean data type, you have string, you can work on it, you have enums, you have waveforms, and there are other types of data as well. So let's see how these data types you can access these data types in LabVIEW, right? And how they look like. So here we have this VI created for you to explain how different data types looks in LabVIEW. So first of all, the most used data type is this, the numeric, and in this category we have different types of data available in LabVIEW. For example, this data type you can see here is the double data type, right? This is the beauty of LabVIEW, that in LabVIEW uh, you can visually see that uh, all the data types have different colors, right, and different thickness of the wire. So not only from the color, but with the thickness of the wire you can see that the data or the type of the data is different. Like here you see there is the integer data type and there is the enum data type. So there's a difference, there's a little difference in between their thickness, right? If you cannot differentiate the color, you can differentiate the thickness, right? So starting from the double data type, right? So double data types are the numbers, the numbers you can basically uh, work with having some decimal values, right? Okay, and you can change the type of the data by simply let me create another data for you. So here I'm creating a numeric control. So by default it has a type of double, right? You can change its type by simply right clicking on it and go to the representation and select the data type you want. For example, I am selecting it to integer data, right? So this is my integer data, right? Previously it was doubled and now I changed its representation to to integer, right? So what's the difference between double and integer? Let me delete this one. It's very simple. So this one is the double data type, this one, and this one is the integer data type, right? you can you can enter any decimal value. Let's say I'm entering 3.5, right? I can implement I can work on this, but when I enter 3.5 here, it will not accept this value. Let's say 3.1. So you see it is automatically converting those uh, values with some decimal points into a particular integer, right? You can create the constants as well. How you can create the constant of this double data type by simply right clicking on the block diagram and go into the numeric and select here double numeric constant. You can also create the integer constant from this as well. Okay, moving onwards, we have Boolean data type. Boolean data types is basically uh, true or false. It only shows true and false, right? So you use it. You have Boolean controls. You have Boolean indicators, right? So here in LabVIEW, if you right click on the front panel of the LabVIEW and go into the Boolean, so you find different types of Boolean controls, right? And you can change them into indicator as well, right? So there is the Boolean data type, and if you are interested to create its constant, what you need to do is to right click on the block diagram and go into this Boolean section, and here you have true constant and you have false constant, right? Moving onwards, we have string data type. So you see the color and the type of the wire is different from the numeric and the Boolean, right? Boolean has green and the double data type has orange wire, and this one is the pink, right? Not only the color but the thickness is also changed. So you can work on string, right? We have different functions through which you can check the length of any string, concatenate strings, right? Replace. So there's a huge number of functions available, right? You can create string constant. If you are not interested to create its control, you can create constant, right? We have empty strings, we have space constants, we have tab constants, end of line constants, and other things as well. So you can work on it. Okay, moreover, if you are interested to let's say I don't know by the color or by the thickness that which data type it is. So what you need to do is to simply press Control plus H. So as you press Control plus H, now you have to move your cursor on the wire. Okay, so you see in the context tab it is showing this is the Boolean data type. You can move into this double, so it is showing numeric double data type. You can move your cursor onto this and it is showing string, right? And so in this way you can also uh, uh, find that which data type the wire is passing, right? So we have enums, we have waveforms, right? This one is the waveform. So waveform data type contains the time, the rate of time, and the values of that particular waveform, right? Moving onwards, we have path. Path can be, it can be the path of any file, right? It can be the path of any anything you work with, right? So it has also a different color and different thickness of the wire. So these are some of the data types on in LabVIEW that you can work with and use in your VIs. Okay, moving onwards. Okay, most of the time when you will be developing your VIs in LabVIEW, so you will see that your run button is broken. Now your run button uh, may look broken due to multiple reasons. First of all, these are some of the causes. There can be other causes as well. So the first cause that is written is the input terminal unwired, right? So if your input terminal is not wired, it will, the run button will be broken, right? Or the data type is mismatched between input and output, or you have or you are wiring input with output or output with output. So let me demonstrate each. So first of all, let's see if our input terminal is not wired. So let me create a new VI for you guys, right? So in many cases, if your input terminal is not wired, this run button will be broken, right? So first of all, let me here create an add function, and let me create a constant, and let me create its indicator, right? So you can see second input of this the second input of this add function is not wired. So due to this, what it is showing that your add contain unwired or bad terminal, right? So what you need to do is to simply click on this, and this error list will appear, which will which you can just click on this show error. So this will show exactly where the error is. So what you need to do is to right click and either create constant or control. So it will simply, this error will gone. Sometimes we create loops. Let's say I have created this while loop. So until and unless I am not wiring this conditional terminal, this run button will be broken, right? Or let's say I have created maybe a case structure. So until unless I am not wiring this, or I am not uh, entering all the cases, this will be broken, right? So this is one of the possibility that your run button is broken. Moving onwards, we have a data type mismatch. Yes, this can also be the problem. So let me delete this one. Okay, let's say we have one numeric control, and let's say we have a string indicator, right? So both the data type of both control and indicator are different, right? So if you try to connect this numeric indicator with this, so it will show the error, right? Now this error is also, you can see the error over here. What is showing that you have connected two terminals of different data types. The type of source, the source in LabVIEW, the source is basically the control, right? And the sink is the indicator. The source will write the data, and the sink will read the data. So here both the control indicator have different type of data, so you cannot connect, and this run button will also came broken, right? Next we have if you wired any input with input and output with output, so it will also show the error. Okay, in LabVIEW, if we have these types of wires, sometimes what happened, if you mistakenly delete any control or constant that is wired with the other functions, depends on this, what happens, your wires get broken. So these broken wires can easily be cleaned up in your block diagram by simply pressing Control and B. So when you press Control plus B, your all the broken wires will be vanished. Okay, let me create another control, right? Now if you connect one control with other control, this will show an error because because the control is one which is the source. Now the source cannot be connected with the source, but the source must be connected with the sink, right? So you can change this to indicator to remove this error simply, or you can delete this wire, right? So these are some of the causes in which your run button is broken, and you cannot basically run your VI, but you have to solve that problem to move onwards. So, so these are the techniques, or these are the some of the causes due to which your run button is broken. Now, once you have fixed all the problems, and but still you are not getting the desired result, so this may be the issue. So in that case, what you will do, let's say I want to take, or let's say uh, what I want to do is to take an average of two numbers, right? So let's do that. So in order to do that, what I need to do is to add two numbers. So let me simply create here an add, and let me quickly create two constants here, right? And let me enter any value. It's 15, and let me enter. Okay, let me enter 5, right? So in order to take the average of two numbers, first of all I need to add them, and then what I need to do is to divide the numbers with some, or with the number of elements. So here we have 2, right? So here we have 2, and let me create an indicator over here, and okay, this indicator will show what it will show. It will show the average, right? It will show the average. Okay, all my program is good, and what I'm doing, I'm running this code, right? Okay, so the average of 5 and 15 is infinity. It is coming infinity. Okay, okay. Why it is coming infinity? It is coming infinity because I know I have to divide it by some numbers, right? But let's suppose this is not a simple code, but this is very big code. You might have block diagrams which contains several hundreds of different functions, and you expect a particular data, a particular output which is not coming. Your VI is running perfectly, but your output is not coming. So in that case, what you will do? So in LabVIEW, we have different techniques through which you can basically debug. You can debug your VI. Debug means you can find where actually the problem is, right? So considering this small example, I am going to tell you how you can sort out the problem, right? So in LabVIEW, you see after this run button, after this run button, we have different types of options available in LabVIEW. First of all, let me tell you about this. Run continuously, right? If you want to run your code continuously without using any loop, you can press this. Your code will be continuously running. Now in order to stop this, you should press this abort execution. your VI will be stopped running, right? After that, we have a pause option, like your VI is running and you want to pause in between any point, you can pause that, right? After that, we have highlight execution, which is the very important feature of LabVIEW as far as the debugging is concerned. So this is this bulb, you are seeing this bulb, this is a bulb, right? Highlight execution. We name it highlight execution in LabVIEW. So let me, okay, so I want to know what in each and every step of this code, what values are passing. I just want to see that. So in order to see that, what you need to do is to press this. So just click on this and this will glow. This bulb will glow. Now it is glowing. So what you need to do is to press this run button and see what values are uh, passing into any function and out from the function, right? So let me run this. So you see 5 and 15 are coming and this is 20, and after 20 that 20 was divided by 0. So let me run this again. So 0 is coming here and 20 is coming from this, and infinity was going, because if you divide any number by 0, the result will be infinite. The result will be undetermined, right? So using this, you can find out while your VI is running, you can see what particular data is flowing. Okay, let me run this continuously and show you. Okay, so this is 20 and 20 divided by 0 is infinity, right? So in this way you can see what data from one port, from one function, from one constant, one control is passing by, right? And moving onwards. So let me stop this. Okay, if you use this highlight execution, your VI will be, your VI will run very slowly. Let's say we have a very complex uh, code, right? So in that scenario, you won't be using this highlight execution because it will take too much time, right? It will take time, it will consume your time. So we do not uh, basically suggest to use in that scenario. So in that case, what you will do? So in that case, what you need to do, you can use this retain wire values. You can also use this retain wire values. Okay, simply press this and run this button. Your code runs one time. After doing so, what you can do is to see the output. So we know 15 and 5 will add, and I want to see what output, what was the output of this add function. So in order to see that, what I need to do is to simply right click on this wire and see the probe. So probe is showing 20, right? Moreover, if I see the output of the divide function, I should right click on this and probe. So the output of this division function is infinity. So it means the problem lies here. This divide function is not giving me the finite value, right? You can close it. Okay, so if this is not pressed, right, not pressed, and you run it, now you again right click on this and see the probe. So you cannot see any value, you cannot see any value after the add function, even after the division function. So you will be able to see only in that particular case when you press this retain wire values. Okay, okay, you can also see the value when your code is running, while your code is running. So let me run this code continuously. So what you need to do is to simply place your cursor onto that on any wire, right? So you see a small p is appearing, which means probe. So let me see what is the output of this add function. I simply need to click on this, right? So it is showing 20, right? It is showing infinity, right? So this also can be uh, one of the way, and it is mostly preferred as far as the debugging is concerned. This method is mostly preferred. Using the probe, you can see what different values are passing by, right? The last but not the least is using breakpoints. What you can do is to introduce different breakpoints in your code. What is breakpoint? Breakpoint is a point when uh, your LabVIEW reaches at that point in your block diagram. It stops executing, and at that point you can see what values are going and coming into that particular function. So how you can use those breakpoints? What you can simply do is to let's say I want here a breakpoint after the add. I want here a breakpoint. So what I will do, I will right click on this, and what I will do is to go here in this breakpoint and set breakpoint. So you see a small red dot is appearing, which is showing that a breakpoint is there, right? Let's say I want a breakpoint here as well. So this is my another breakpoint. Now if you run your VI, your VI will get stopped. Your VI will be stopped. It will not move forward to the next breakpoint. So I can basically see the value at that particular break point. So let's say we want to move forward. So press this, and here we are ahead and finish debug. So this is also one of the way through which you can debug and find out the problems in your VIs. So this is all about for this video. So see you in the next video. Allah Hafiz.